This is a viewer suggestion, to see if tetrahydrofuran can be oxidized by sodium bromate. Well, we managed to beg and borrow some THF, and we recently accidentally received some sodium bromate, so why not give it a go? Let's do a very small scale experiment first so we know what we're letting ourselves in for. Here's some sodium bromate crystals. Let's add some water to make up a solution. It's not incredibly soluble, so we'll warm it just slightly. Okay, here we go. The lukewarm solution. And here's some tetrahydrofuran. This is a cyclic ether, as you can see, and a 5-membered ring with a single oxygen in. It's a watery clear liquid with an unpleasant headache-inducing aroma. Okay, let's get some into the bromate solution. Temporarily there's a few bubbles of THF in there, but unswirling it mixes completely homogeneously with the aqueous solution. And then basically does nothing. There's no obvious reaction. Let's add a drop or two of 50% sulfuric acid. It sounds a bit scary, like watering a hot deep fryer. And then it kicks off. Holy crap! That's a lot of bromine and heat, and with just a few small drops of reagents. If we want to scale this, we're going to need to do it carefully. Well, we won't spoil the surprise, but we did have a bit of fun with this one later. If you're going to do this reaction, then do it small. Let's look at the setup. We're using the large 1-liter flask. It's a bit old and dirty, unfortunately. This has got good magnetic stirring, and temperature control could well be important, so we've got a thermometer so we can keep a close eye on this. And a very efficient condenser with lots of ice-cold water. Trust us on the condenser. Don't go halves. Just trust us. Okay, we're set up, so let's start preparing the reagents we need. Here we've got 30 ml of 50% by volume sulfuric acid. We're going to use a rather larger dilution than our test, so we're going to mix this with 200 ml of water. Let's get this into the flask first. In order to tame this, we're now going to add 15.6 grams of solid potassium hydroxide. This will convert the sulfuric acid into potassium hydrogen sulfate. Still acidic, but not quite as potent. That's such an awesome sound. The temperature inside is now about 40 degrees C though, so not too much. We've got the flask set up in the cooled water bath, so we'll let this come back down to about 20 degrees again. Okay, here's our sodium bromate. This is 42 grams, which is going to be the same stoichiometric amount as the THF we use and the sulfuric acid. It's an innocuous looking white crystalline powder. A bit like sugar or salt. But don't let it fool you. We'll try to dissolve this in the minimum quantity of water possible. And we get there with about 200 ml of solution volume. Let's get this into the flask. A white precipitate forms. Maybe this is just because of cooling, or perhaps it's potassium bromate. We're not sure. Let's get the stirring going and continue anyway. And finally, Here's 20 grams of tetrahydrofuran, about 23 mils. Again, we want to dilute this a bit, so we're going to add 50 mils of water. Okay, we're now all set and ready to add this very slowly. Temperature is about 20 degrees in the flask. Okay, let's do this. Well, that's an anticlimax. Let's try again. We did notice in the test at the start that the main reaction kicks off after a while, so perhaps it needs heat to start up. So we put the flask on a hot plate and let it warm up a bit. A little more can't hurt now, can it? Soon the solids dissolve again. Temperature is now around 30 degrees C. But there's still not even a hint of yellow bromine color in the mixture. So we keep on heating. And very slowly a yellow color starts to appear in the mixture. We're honestly wondering at this point if we really need to bother with the condenser. Do not remove your condenser. Let's just help it along. I mean, another half gram of THF can't hurt, can it? Interestingly, the bromine color fades slightly on addition. 40 degrees C now. About this point we suddenly realize that in our excitement and impetuousness we've added about a third of the THF mixture. And suddenly we've actually got some orange-colored bromine vapor starting to appear in the flask. So this is a good sign. Now at 50 degrees. What the heck? Let's try to jumpstart this thing. The two completers looked at each other. Deep down in the bottom of their stomachs they somehow knew that their sins would shortly be punished. Like a guilty child standing in ominous dread outside the headmaster's office. As the mixture gradually grew deeper in color they tensely waited for their punishment, knowing they had unleashed forces beyond their control. Like the sound of the rod swishing through the air. The gentle reflux which commenced triggered a sharp apex of anticipation on their senses. So they quickly switched on ventilation and readied an ice water bath. And at about 65 degrees C the reaction commenced full swing. And a door to a hellish parallel universe opened up in our flask. We survived. Actually, we did pretty well. The ice-cold water doing the cooling in the condenser was a good 40 to 50 degrees by the end, but it saved us. We added the rest of the DHF mixture slowly and let the reaction proceed a bit slower with a gently reflux. We then let the mixture stirring and refluxing for the next 4 hours. The bromine didn't fade away. If anything, it seemed to disappear and then come back again in cycles. Weird. At the end of this time we decided to quench the reaction mixture using saturated sodium bisulfite solution, until the color had disappeared. Just some strange red blobs jumping around. Okay, we decanted off the reaction mixture and left the blobs behind. Let's work this up and see if the punishment from the chemistry demon extends to yield of product as well. We extracted the reaction mixture using 240 ml portions of dichloromethane. Okay, let's do the second 40 ml DCM extraction. The aqueous mixture remaining we treated with bleach and then extracted the bromine using DCM, and we've got a nice 13 grams of bromine here to play with now as well. Here's our DCM extraction. We dried this using anhydrous magnesium sulfate, and then decanted the DCM solution into a flask. Okay, let's boil off the DCM and see what's left. All the DCM is gone and the mixture got to over 100 degrees C, so there's no water here either. We've got a pale yellow colored liquid with an unusual subtle aroma. Reminds us a bit of the seaside. Okay, well, it's not much, but it is enough to distill, so let's try. We set up for distillation using a heating mantle as a strong heat source, and a thermometer so we can record the temperature of the distillate. We insulated the still head to make it more efficient as well. On heating, the mixture darkened, almost to a black color. As distillation starts, the temperature shoots up. And then we start to collect the clear liquid distillate, with a thermometer vapor temperature of 200 degrees C. Distillation was pretty quick, and at the end the black carbon-like material was left in the boiling flask. In the end, this took a dose of the arachidonic solution to clear the last black residue away. So here's our distillate. There were no other fractions at all, and it's a slightly pale yellow color, but this could be some decomposition material that condensed because we could see the distillate in the boiling flask was colorless. Here we go. 6.2 grams of the watery product, boiling at 200 degrees C and with an unusual faint aroma of seaweed. So what is it? Well, we're guessing you might have figured it out. It's this rather infamous compound here. Gamma-butyrolactone, otherwise known as GBL. It's infamous because it's a sedative drug, a bit like ethanol or chlorohydrate, but quite potent. A lot of countries made it illegal a few years back because it was being a bit too widely abused and the media had a field day about it. Well, we're certainly not planning to eat it. It doesn't smell very pleasant, and having seen the reaction it came from, it's not particularly appetizing. We'll be celebrating that the reaction worked and that we survived it using something a bit more traditional. Thanks for watching and stay tuned.